Hello, everyone. Thank you for joining our virtual meetup. Today's topic is going to be AI, artificial intelligence, to combat malaria, a very important topic. And to discuss this topic with us today is Arbel Vigodny. Arbel is Chief Operating Officer at Zapp. That's spelled Z-Z-A-P-P. I think that probably has something to do with the sound that a mosquito makes, but I'll let Arbel explain that later. Zapp designs technological solutions for malaria elimination, a great cause. Again, we talk about AI for good a lot. This is a good example of that, AI for good. Arbel interfaces and coordinates with clients globally, including researchers and government officials. He holds a BSc in Life Sciences from the Hebrew University and a MSc in Mental Health from London Metropolitan University. Once again, we are going to let Arbel walk us through his presentation first. Please post any questions you have using the QA button as always, and we'll respond to it once the presentation is over. So once again, Arbel, thank you for joining us today. I know it's late in the evening for you there, so we truly appreciate you being with us today. Take it away, Arbel.
Thank you, Pramod, for the introduction. I'm very happy to be invited. Let me share my screen with you guys. I'm joining from Tel Aviv here, where Zapp is based. And we develop software to make malaria control operations more effective. We're currently, as you can see, competing in the IBM Watson X Prize AI, which is a 4-year-long competition. Actually, a 5-year-long competition now that the finals have been delayed due to COVID. And it's for organizations that use AI in ways that could make a positive impact on the world. We're currently 10 semifinalist groups, and probably finalists will be announced around fall for this. And as Pramod said, yes, the name of our company, Zapp, is based on the sound that the mosquito makes and how you zap the mosquitoes to get rid of malaria. And also the app stands for a mobile app, which I will get into in a minute. The issue of malaria that we deal with is quite a huge problem in the developing world, and mainly in sub-Saharan Africa. The yearly death toll from malaria is about 450,000 people. And unlike COVID, most of the deaths are young children under 5. Because with increasing exposure to the parasite, a certain level of immunity builds up. And as you can imagine, a lot of effort goes into finding ways to combat malaria. And every country in sub-Saharan Africa has a national malaria control program, and a large portion of the funding comes from international organizations as well, from governments, mainly the US and the EU. And the alarming trend that we've been seeing in recent years, we've had a few decades of steady declines in malaria cases, and we're kind of reaching a plateau, as you can see, where we're achieving less and less progress each year. In some countries, we're even seeing the rates of malaria increase. And basically, Zapp started from the idea that was quite prevalent in the previous century, that malaria can be eliminated fairly quickly if you use the right tools. Malaria is only transmitted through the bite of a mosquito, and only one genus of mosquito, only the Anopheles mosquito. So by targeting these mosquitoes, we can slow transmission enough to make the disease disappear. And we don't even have to get rid of all the mosquitoes to do this, just enough so that the transmission slows down and the disease stops propagating within the population. So there are several main methods that are used to fight mosquitoes. Currently today, you can spray the walls of houses with insecticides so that when mosquitoes rest after they take a blood meal, they don't make it to the next meal. You can spray water bodies with more specific mosquito larvicides that target the mosquito larvae. because the first few stages in the life of mosquitoes are spent in water, and of course, if you spray those water bodies, they can't develop. And another thing that you can do is you can sleep under bed nets, and I'm sure most of you are familiar with that because you always see it in movies where people traveling to tropical climates are sleeping under bed nets. The thing is that these methods, they don't work the same in different environments. Of course, if you used all of the methods at 100% everywhere, you would be able to stop malaria quite quickly. And it was certainly easier for developed countries with more resources to do that. And that's how come we don't have, there's no malaria in North America and Europe. But with limited budgets in the developing world that carries most of the malaria burden, it's important to optimize the interventions to reach the most impact at the lowest budget. And for us, that's where AI comes into the picture, because it can be a really great tool for optimization problems. And I want to start with a specific example. So I said earlier that to control malaria, we can spray the walls inside houses and we can spray the water bodies. In a village such as this, in this example, assuming the cost and the effectiveness of spraying water bodies and spraying houses is equal, then you can see that spraying the houses here makes more sense because there are more water bodies than houses, so it would be cheaper to just spray the houses instead. But if it's the same water body density, but a different population density, then spraying the water bodies becomes more cost effective. And it's those differences that at Zapp we wanted to be able to account for when we design interventions. And so we chose to use AI to do that for us. And that's how Zapp came to be. So roughly to explain how the system works, so to start, the system uses machine vision to analyze satellite imagery and identify the exact locations of houses automatically from these images. So in areas where mapping is often lacking or inaccurate or outdated, it's important to know where, first of all, where the individual houses are that you would need to be targeting. Then we use a different algorithm to predict the locations of water bodies. So for that, we analyze topography first, and we combine that with climate data and weather to determine what areas specifically are going to be most likely to develop water bodies that are suitable for mosquito reproduction. If we combine the two, we use a simulator to predict first where the malaria hotspots are going to be. It's usually houses that are close to water bodies. So we simulate exactly what the locations are, but then we also simulate what specific intervention strategies or what specific intervention combinations would be suitable for each individual community. So basically each village in the intervention area that is being planned. So what you get is the input is the physical coordinates of the operation where you want to work, and the output is a strategy plan of where each intervention should be implemented down to the house level. And taking into account population distribution, climate, topography, also the prevalent mosquito species. Some mosquitoes tend to bite indoors and some tend to bite more outdoors, and it changes how effective spraying the walls of houses versus spraying water bodies is going to be. And this would all be very difficult to achieve without an automatic system like the one we use. And so the next hurdle that we had to face was a way of getting this into the field, because what results from our system is very location-specific recommendations. So exactly spray this house or scan this area for water bodies. But in order to get workers in the field to actually do these things, that was another thing. And it's very the infrastructure for these things is not the best. So you have to find sort of creative ways of getting these recommendations out into the field. And the way we chose to do it is through a mobile app. And so we developed a location-based, map-based mobile app that uses GPS to help translate all of these general recommendations that we have from our AI system into specific actionable tasks in the field. So the system, the app gets all of these AI recommendations, and it sends the field workers, let me see if I have it sends the field worker exactly the route that they need to take in order to scan all of the water bodies or all of the areas for water bodies and spray them, which houses they have to go in order to have the most impact. And it's this combination of AI and a mobile app that enables us to really get our technology into the field and see results. We also have a control center where all of the information, all of the data that is collected through the mobile app, the workers basically, we tell them where to scan for water bodies, and we tell them which houses to spray. But the workers who are out in the field doing all of this are collecting data such as the types of water bodies they're finding, the exact locations. They also take pictures, and everything that they do out in the field filters into this control center where we can see exactly what's happening in the field, and we can monitor, see where an intervention isn't being implemented in enough coverage to get to the results that we want, to the impact we want and we're looking for. And basically the AI can analyze all of this data to come up with new recommendations based on the things that we're finding in the field and the more accurate data that we're receiving. How can we change the intervention to make it even more cost effective, or to make sure that if we are looking to eliminate malaria in a certain period of time, do we need to implement additional interventions, or are we implementing interventions excessively and could save the funds and use them somewhere else? So this is how we do that through the control center. And I have a few pictures of us in the field. We've worked in South Africa. We've worked in Kenya with a research institute that's called the International Center for Insect Physiology and Ecology. We also have operations in Ghana, where we test our mobile app in collaboration with the AGAMAL, Anglo Gold Ashanti Malaria Control Company, which is owned by a gold mine, and this is sort of their outreach program. And so we help them, we provide them the app, and they help us test the app and make sure that everything is going well and is effective. And in Zanzibar this year, I think a lot of people who hear AI for malaria expect some sort of robots to be targeting the mosquitoes. So this is the closest thing that we have for that, where we have drones that are not delivering the insecticides, but that are scanning the area and identifying the water bodies instead of the people, which is currently the way that most places it's happening. So in Zanzibar, we were supposed to start this year, but because of COVID, it got postponed for next year. We'll be using drones to get the water body imagery and send the workers to spray those water bodies without having to scan large areas. Yes, and this is our system. I'd love to answer any questions.
Yes, thank you, Arbel. That's very fascinating, to say the least. Can you hear me okay?
Thank you. Yes.
Yes, great. Yes, I do have a few questions. And again, if you have a question, please go ahead and ask that using the Q&A button. Of course, this recording will be made available. And Arbel, hopefully you don't mind me sharing your LinkedIn information with our members if they want to.
You can also go to visit our website, and there's a contact form as well, and we read all those messages. So you can also contact us that way.
Okay. Great. So I do have a few questions. If you can tell us how many countries approximately are using this technology at this time? Just a ballpark number.
Right now it's being used in Ghana, where actually we're supposed to be starting an operation in July that'll be covering quite a large area in Ghana, in the area of Obuasi, where this operation, wait, it's not, my share screen is not working, where one of the operations that I showed is taking place. We're also working in Ethiopia currently. We also have a big operation there. And we are planning to perhaps go to Mombasa next in Kenya. So these are currently the countries that are using it.
All right, sounds good. You may want to just disable your share screen so that we can have a conversation. You can
Yes.
stop sharing it. All right. So the next question I have for you, Arbel, is in terms of how long countries have been using this technology. Can you give us some ideas? Is it brand new?
So this is quite new. I mean, we started this, so the AIX Prize, that's the competition we're participating in, that started in 2016, and we joined, and Zapp also started in 2016. We joined the competition late as sort of an additional round of the competition. So we joined in 2017, and so we've been working on the app for maybe since 2016, and the AI portion of our technology has been going on for maybe 3 years. So it's quite new, and it's taken quite a long time to develop because we're relying a lot on collaborations in sub-Saharan Africa to gather data, and malaria is very seasonal, so a lot of our work is kind of dependent on the malaria season. So we would have a certain development in the app over several months, and then test it out in the field. And then in order to implement changes, we would have to wait for the next year or the next malaria season. So luckily, we were able to, in different places in sub-Saharan Africa, it's different seasons, but so we were able to sometimes get more done in a year than one operation. But since it's a seasonal thing, there are a lot of delays. And if you miss the season, if, for example, COVID is happening now, we were supposed to have a big operation in Mozambique. And then COVID happened and it got pushed back to next year. So, yeah.
Yeah, that's unfortunate. So in terms of the metrics that you're going to be looking at, how do you kind of measure the success of your program? Is there any way you can measure the before and after in terms of malaria cases or fatalities? How do you prove that your efforts are working?
So a lot of these, almost every country in sub-Saharan Africa has a national malaria control program. And these programs collect data all the time about the mosquito prevalence, the types of species of mosquitoes that are prevalent. The hospitals collect data on malaria cases. So we kind of use a combination of that. The malaria cases kind of lag behind mosquitoes. So first you sort of see the mosquitoes responding to the intervention. And then there's a sort of lag, and then you see the malaria cases going down as well, accordingly. So we use both. We use data from these national programs. We try to gather as much data as we can in our own operations, so that we have like supplemental mosquito collections. And malaria cases from hospitals, from clinics, whatever is available to us through the people we work with. Because basically we're kind of guests in the countries where we work, and we're always collaborating with one organization or another. So it can be a malaria control company, like in Ghana. It can be the government, like in Zanzibar. Different people who have access to this data and can basically share it with us.
Got it. Thank you. So in terms of the adoption of the technology, what have been some of the biggest challenges Because I assume that you had to work with the government officials a lot, to get buy-in from them. So what are some of the challenges in expanding within the countries that you're already in or new countries that you may be trying to help?
Yeah, so one thing was the thing that I mentioned already, that is seasonality, that you sort of, it's a year by year thing. So if it's not happening one year, it takes another year for it to start happening. So a lot of public health has to do with the government. And so you have to deal with the government and government contracts and things that happen on maybe a slower pace than the private market. So that's one thing. Another thing is what we're taking advantage of is the fact that now the mobile technology in places like sub-Saharan Africa and developing countries where the malaria burden is concentrated, is that there are more and more mobile phones, and smartphone ownership is on the rise. But it is still sort of a barrier in certain places. So certain countries we work with are more familiar with smartphones. People have smartphones, so that we just go, they download our app and start working. In other places, we have to purchase phones for the field workers who are implementing these interventions, and sometimes we even have to sort of have advanced training and kind of tailor the training to the place where we work. Some places don't need training at all. They just, they're familiar with Google Maps, so they've used it. Our app is map based as well, so that kind of flows into that. But in countries where they don't really use Google Map or navigation apps, there's a lot of new things to learn about, how to use the compass, what everything means. And so that being able to tailor our training based on that, being able to plan, to budget for internet connectivity, for mobile devices, for places to be able to log into our control center, which is desktop based. Those have also been challenges that we faced.
Thank you. So in terms of additional features and capabilities that you're planning for your technology, could you tell us a little bit about what you have in store?
So actually, COVID has presented us with an interesting opportunity, because when you're thinking about the interventions that are prevalent at the minute for malaria, a main one is, the biggest one is bed nets. But the second biggest one is house spraying. And house spraying requires going from house to house. The workers go from house to house and spray the walls of the houses. And a lot of people were afraid that this would be a way to spread COVID. And so a less common intervention, which is spraying water bodies, which our app is able to optimize, is now becoming maybe more COVID friendly. And so more countries are considering it as an alternative. And there's not a lot of systems that are in place to help you do that. So we kind of are taking advantage of this opportunity to promote this portion of our technology. And this is actually the operation I was talking about that we're starting in Ghana that will be focused on spraying of water bodies. It's called larviciding. So that's kind of something that we took advantage of recently. In addition, we're also we're participating in this IBM Watson competition, XPRIZE AI, and they've provided us with resources from IBM Watson that could help us use natural language processing and their tools to augment what we have to offer. So we're also looking into that right now. We're very lucky in that way because we're getting access to a lot of this state-of-the-art technology that's going to hopefully be able to increase what we can offer our clients.
Absolutely. Thank you. So I do have one final question for you here. So a lot of AI developers, practitioners, and even AI investors may actually be listening in right now or later, and they may be curious how they can get involved, whether it's doing internships or, because it's really AI for good. And I know a lot of AI developers want to contribute to causes like that, as well as, in terms of people who are looking to invest, or even companies. So what kind of help are you, if any, are you looking for at this time along those lines?
Well, we're always happy to talk to anybody who's interested in helping out and getting on the AI for good train. And with malaria, malaria is actually a very, in terms of the investment that you put in, it's the most bang for your buck. AI for good is concerned, because one bed net that you provide a child that is able to sleep under can basically prevent him from getting malaria, and can save a life. So in terms of AI for good, this is probably one of the most cost-effective in terms of impact. And we'd love to explain more about what we do to anybody who is interested, and feel free to contact us through our website. We read everything, so we'd be happy.
All right. Thank you, Arbel. Personally, I was very fascinated by the way you walked us through what your technology does. And I'll be keeping a close eye on how you guys do. And I'll try and promote your company within the circles that I know of within AI and data science. Once again, Arbel, thank you for joining us today. I know it's late in the evening.
Thank you for having me. It's been great.
Yeah, absolutely. Thank you. Good luck.
Have a good
day.
For
everything you're doing. All right. Good night. Thank you.
Bye. Good night.
Bye, everybody. Thank you.